All right, so we're going to be graphing systems of inequalities. We're going to use the grids to create a graph of each linear inequality below. Then we're going to answer A through C. So first off, we're going to graph these. When graphing, I can see that I'm going to start by graphing at a positive 6, which is the point 0.06. And then I'm going to go down one to the right one, down one to the right one, down one to the right one. And you only have to do so many of those points. I prefer to do extra just to be safe. And so we've graphed that now. Now that we've graphed it, we can also see that I went ahead and I did a solid line, and it was solid because it was less than or equal to. And then you would go ahead and shade. Less than or equal to are numbers that are less than or equal to, which is why we have that one line. Now, I'm going to also go ahead and graph the other one, and I'm going to pay attention to the fact that right here it's going to be a dashed line because that's important. I'm going to start by graphing at -6, so -6, 0. And then the slope is positive, so up one to the right one, up one, right one, up one, right one. And I'm just going to keep going ahead and doing it like this so that we can see that it is a dotted line. And then I would also continue the dotted line that way. So it's a dashed. Now, it also says that this is greater than or equal to, so I'm going to shade above. Now, we're going to list 3 ordered pairs that represent solutions for both inequalities. There's a lot, but when we're looking at the first one, it's anything in this region. So I see that it has the point 0, 0. I'm going to go ahead and list that point. I can see that the point 0, 0 is also in that point right there, so that one would work. I'm going to list the point 2, -2, so over 2, -2, that's down in this area. I can also see that the point over 2, -2 is in this area right here. So that one would be in both of them. Lastly, I'm going to list the point -6, -6, which is down in this area. And I can also see that -6, -6 is down in this area. So those would all be in both of the inequalities. Is 6, 0 a solution to both inequalities? So let's test that out. So 6, 0 over 6, up 0. That would fit in that point in the red, so it does work on that one. But then let's check over 6, 0 over here, which is a little bit off to the right, as you can see, and so no, that one would not work. So when it asks, will it work, you would say no. Only the first inequality, since the second one has a dash line. This is why it's important to go ahead and graph these points also, these lines into Desmos, to make sure you know what you're doing. If the inequalities were graphed on the same coordinate plane, how would you identify the solution set for both? Well, when you're graphing them on the same one, you're going to look at the overlapping shaded regions. All right, let's continue. So, systems of inequalities. A system of inequalities is a set of 2 or more inequalities with the same variables. The solution set to a system of inequalities includes the set of ordered pairs that make all the inequalities in the systems true. When graphing a system of inequalities, the solution set is represented by the intersection of the overlap of the shaded regions. So we're looking where they both overlap. So what we're going to do here is we're going to solve each system of inequalities that it's graphed and then state whether each ordered pair represents a solution to the systems. All right, so let's graph this first one right here. I'm going to do the first one in red. I'm going to see that it does have a dashed line because it is not equal to. So we're going to go ahead and graph that. It says graphing at the point 2, so 0, 2 is my y-intercept, and then up 2 to the right 1 because my slope m is 2 over 1, and my b or my y-intercept is 0, 2. I am going to graph a couple of extra just to make sure I'm good. It's very important to also use a ruler to make sure you're graphing correctly. I'm going to leave it as dots since it is just being dashed, so we could add in little dashes in between, or just leave the dots. Then I'm going to look at the next one, which is right here. It's going to be a solid line because it does equal it. My m, which is my slope, is a -1/1, and my b, my y-intercept, is the point 0, -3. Before I do that, I am going to go ahead and I'm going to shade that red part. It's less than or equal to, so I'm going to shade everything underneath when doing that, so make sure that you do that as well. Then looking at the next one, I'm going to do in green. I'm going to start at the point 0, -3. And then my slope is down 1 to the right 1. And so I've graphed several points, and it was a solid line. And it says that it wants anything that is greater than or equal to. So I'm going to shade greater than all right there. So I'm looking in that red and green area. So I'm going to do this in blue to see the difference. Is the point 0, 0 in both of the shaded regions? Yes, so that one works. Then we're going to look at the point 4, -3, so over 4, down 3. That point is in both, so yes, that would be correct. And lastly, we have the point -2, +3. Oops. And no, that one does not work because it's only in the green region. All right, looking at the next one, we're going to see that I'm going to graph in red again. This one is a solid line. It's solid because it does equal it. I can see that my b or my y-intercept is the point 0, 0, and my m or my slope is 1/2. So I'm going to go ahead and graph that. So 0, 0, and then up 1 over 2. Oops. Again, I am graphing extra points just because it makes sure that I do it right. And again, this was a solid line, so we are going to draw a solid line through, and it says y is less than, so we're going to shade less than. Then I'm going to do in green the second one. I can see that my b, I don't have my b yet, so I have to solve. When I move the x over, I subtract x from both sides. So y is less than -x minus 4. So now I can start graphing where my slope m is -1/1, and my b or my y-intercept is the point 0, -4. So I'm going to graph 0, -4. So there's my first point. And then my slope is down 1 to the right 1. And again, I'm just going to go ahead and keep putting quite a few of those. I do see that this is going to be dashed, and it's dashed. I'm just going to use my dots as that. Now I'm going to shade it, and it says it wants numbers that are less than, so I'm going to shade less than, and it's going to be the part where I have red and green. So I'm going to use blue for that. 0, -4, so over 0, -4. I see that it's on an actual point, so that's a dashed line there, and because it's dashed, it does not include that, so no, that would not work. If it was solid, it would have worked, but since it's dashed, it does not include that point. Then we have the point -3, -6. And I do see that, yes, it's in both of the shaded regions, so that one is a yes. And then -5, 0. I see that it's only in the green section, so no, that would not work. So again, we're looking for the area that they're both shaded. All right, so we're going to keep graphing. I'm going to start with red again. I see that this is going to be a solid line. there is no slope, so that's a 0 slope. And my b or my y-intercept is the point 0, -6, so I'm going to graph that. So I can see that it is a solid line going straight through both directions here, and it says that y is greater than or equal to, so I'm going to shade everything above the line. Then using my green pen here, I'm going to have to go ahead and solve, so I'm going to subtract x from both sides, which gives me 2y is less than -x plus 4. Divide by 2, divide by 2, divide by 2. So then y is less than a -1/2 x plus 2. I can graph my slope as a -1/2 and my b or my y-intercept as the point 0, 2. Then I can see that this is going to be a dashed line. So when I graph at 0, +2, so that's my first point right there. And then my slope is down 1 to the right 2, down 1 to the right 2. And I'm going to go ahead and keep doing that. Since this is a dashed line, I'm going to use these dots as my dash. And then it says that it is going to be less than, so I want to shade everything below. And I'm only looking at the red area, or sorry, the double shaded area. All right, so once again, my m or my slope is 2/1. My b or my y-intercept is 0, 5. I can see that this will also be a dashed line. So I'm going to graph the point 0, 5 first, and then up 2 to the right 1. I'm going to go ahead and keep adding points just because those are going to represent my dashed line. All right, and then when I shade this, it says greater than, so I want to shade everything that's greater than. Then I go through and I can see that I need to go ahead and I need to solve, so I'm going to add 4x to both sides, which now gives me 2y is less than or equal to a 4x minus 8. Then I'm going to divide by 2, divide by 2, divide by 2. Y is less than or equal to 2x minus 4. My m or my slope is 2/1. My b or my y-intercept is the point 0, -4, and this is a solid line. So I'm going to graph the point 0, -4, and then I'm going to graph my slope up 2 to the right 1, up 2 to the right 1, and what I can see is that these are parallel to each other. And they never actually cross because this is numbers that are less than, and so all of this is less than, and so they never cross each other there. Toby believes that if the lines in a system of linear inequalities are parallel, there will always be no solution to the systems. Do you agree or disagree? Well, if the lines are parallel, it depends on where the y-intercept is at. So if we would have shifted one of the lines on question number 4, then they could have still overlapped. So that's not necessarily true. So that's important to see where the shading is and graphing correctly. All right, so let's keep going. We're going to use the systems of inequalities shown to answer A through C. So what we're going to start with is we're going to write the systems of inequalities that they represent. So we're going to start with the solid line. I can see that it crosses at a +6. So, and it crosses the y-axis, so that would be y, and these are numbers when shaded are below. So y is less than, and it is equal to, because it's a solid line, so y is less than or equal to 6. Versus when I look at this other one, I can see that it crosses at the origin, and my slope so from there is up 1, 2, 3. So up 3 over 2. And when I say up 3 over 2, I'm going to go ahead and simplify. So it wasn't necessarily 3 over 2. It was up 6 over 4. And that simplifies to 3 over 2. So I was simplifying just because they were both graphed with the same numbers on the axes. So then that is the slope for that one. And so then y in this case, I can see it's a dashed line, so it's either going to be greater than or less than, and I can see that it's shaded above. So it's going to be y is greater than 3 over 2x. List three ordered pairs that the solution of set. There's a lot of opportunities here of things to put, so I'm going to graph this one right here. That's the point -6, 0. I can see that they have 0, 6 right here. And I can see that -10, -8 is also overlapping, so I'm going to put that one. There's a lot of things that you could have put that's not necessarily a right or wrong. List three ordered pairs that are not in the solution set. So I'm going to go ahead and I'm going to say the point -4, -6, because -4, -6 is going to be right there, and it only is in one section. I can see the point 8, -4. So 8, -4, again, it's only in one solution set, so that's not going to work. And then lastly, 4, 10. And again, all of these, there's multiple things that you could put. All right, so Jessica bought hot dog buns and hamburger buns for a neighbor cookout. The total number of hot dogs and hamburger buns was less than 50, and Jessica bought more hot dog buns than hamburger buns. If X represents the hamburger buns, so X is hamburger, and I'm going to put an H above the X just so I remember, and Y represents the hot dog, so I'm going to do D for hot dog. The situation can represent the systems below. We're going to graph the two equations first. So starting with this first one right here, I'm going to have to subtract X from both sides so that I have Y is less than or equal to. So then that would be Y is less than -X plus 50. I can now graph that at a +50 and then down 1 over 1. Since it's by tens, I can go down 10 to the right 10 each time so that I know that I've done that correctly. It's not equal to it, so it's a dashed line. And it says that Y is less than. So I want to shade all of this that's less than. Now I'm looking at Y is greater than 1x, so I can also do a 10 over 10. So I'm starting at the origin, up 10 to the right 10, up 10 to the right 10, and it still has that slope. I'm going to use the dots again in this case as my dashed line. If you want, you can add the dash just to make sure they're not connected. And these are numbers that are greater than, so there's the greater than part, and you can see where they overlap. List the possible combinations of hamburger buns and hot dog buns that Jessica could have purchased. There's a lot of things that we could have put here, but we're not going to have a negative amount, so we're going to go over 10 up to 25, so we can use the point 10, 25, which would be 10 hamburger buns. And I knew that I could use hamburger as 10 for the X because that's how I labeled it and it was written in the question, and then 25 hot dog buns. Are there any ordered pairs in the solution set that do not make sense? So any negative value would not make sense because you don't buy a negative amount of something. You are also not going to buy part of a hamburger bun or a hot dog bun, so then it wouldn't make sense if it was a decimal either. If you have any questions, please let me know.